Um, let us start formally. So cloud computing, yesterday we were talking about cloud computing. So today we will start with the introduction, formal introduction to cloud computing. So what cloud computing is all about. And uh, yeah, so these are the things that we are going to look into. The first one is about some introductory issues, introductory concepts. Then we are going to look into the overall architecture, the high-level architecture of cloud computing, the different components, the different building blocks in cloud. We are going to look into the service and data management models in cloud. Then federation, concept of federation, presence, identity, privacy, etc. Some case studies we are going to look into, and then what is the future and some of the demos. So this is all. I mean, this is something that I also told you yesterday. So this is all going to be the overall outline of this particular course. So what is cloud computing? So this is something that I have taken from NIST, the NIST definition, and the corresponding source actually is given at the bottom of the slide. And please remember that time to time, many of these sources that are given at the bottom, you should definitely open those sources, try to go through those sources, because that will give you much better idea beyond whatever I tell you in the class, right? So let us try to understand what is cloud computing. So cloud computing is a model for enabling ubiquitous, convenient, on-demand network access. Okay. Access to what? Access to a shared pool of computing resources. And these computing resources could be in the form of networks, servers, storage, applications, services, and so on. So let us try to understand whatever we have gone through so far in this definition. Ubiquitous, convenient, on-demand network access. So you see, let us first try to conquer these terms. On-demand network access, right? So on-demand access to a shared pool of computing resources. Okay. So whenever I need some resource on demand, I should be able to get that corresponding resource. And these resources we are talking about again as computing resources. These resources are in a shared pool, right? It is shared. So it is something like this, that there is something which is invisible to us, which has lot of computing resources. We have, let us say, giant servers and other computational resources, which when required, we should be able to get access to on demand. And from anywhere in the world, we should be able to get access to. So it is ubiquitous, convenient, because just by clicking some some interfaces, let us say web interfaces, clicking on some web interfaces, we should be able to get the access to those shared pool of resources. So we have a giant pool of computational resources. We as users, we can use any part of the giant pool of resources, and these resources are shared. So to me, I might feel that I have complete access to those resources, but actually those resources behind the scene are at the same time being shared with many others in the world, and we are completely sharing those resources in a certain manner. So what is that manner is something that we are going to learn in the course. Okay. So we have shared pool of resources. Those resources anytime from anywhere in the world, in a very convenient way, not in a lot of configuration will be required, etc. So just through some few mouse clicks, we should be able to get access to those computational resources in an on-demand manner. So that means that if I need certain amount of certain, let us say certain amount of RAM, certain CPU, etc., I should be able to use it. And then if I need even more, I should be able to get access to those more resources as and when required. Okay. So that can be rapidly provisioned and released with minimal management effort or service provider interaction. Okay, so this provisioning of these resources can be done rapidly and with minimum effort, right? So it's a very spontaneous kind of thing that happens behind the scene, spontaneously. So it is this. So that is the way these cloud resources are provisioned. Okay, and whenever you need more, you use more resources, and whenever you do not need more resources, you release those resources automatically. This will happen automatically, right? Quite seamlessly it is going to happen, and that is the beauty of it. So for all of these, all of these issues that I told you, these features that I told you, all of these are going to be managed through some kind of a service provider called a cloud service provider, right? So the cloud service provider is going to help you manage all of these different features. And these features typically are made available through some user interface, typically a web-based user interface. And whatever you need, those resources, whatever you need, you utilize. And whenever you do not need, those resources are going to be released for others to use further. And even like when one is using a certain part of the resource, it is quite likely that there is some other user in some other part of the world who is also using that resource at the same time. So there is some kind of sharing of resources that takes place. Okay, so this is all about cloud. And so cloud basically has different essential characteristics, 5 essential characteristics, which we'll talk about. And there are 3 service models primarily and 4 deployment models. So we are going to talk about all of these. What are these service models? What are these deployment models? We are going to take up one by one, and we are going to follow like what all these models are all about. Okay, any questions so far? So as I said, that please make sure that you go through the corresponding sources that I give you, and that those become the reading materials for you, right? So at the bottom of this slide, as you can see, the corresponding NIST source is given, and please go through this document, not just merely depend on whatever I tell you in the class. This is a PG level course once again, and in a PG level course, it is expected that you all take your learning beyond what is told to you in the class, right? So you have to take your learning beyond that also. So let us try to understand the evolution of cloud computing. So cloud computing, this term came into being much later. And as I told you, essentially cloud computing is not a completely different type of new technology. Yesterday I told you that it's a technology that uses different other existing technologies to build something which has a new type of service offering. And that new type of service offering is the quote unquote the new part, and that itself is very attractive, right? So there is for me, I see cloud computing to be more service oriented than technology oriented, because technology wise many things were all existing, but service wise actually this kind of new type of service offering that it brings, it's very attractive, right? And also so the business, there is a lot of business value of cloud computing, and that is another attractive aspect of cloud computing. So all these things were as I told you yesterday also, like all of these were very attractive earlier, But now, this cloud computing is not nothing futuristic, right? So these have become part and parcel of life. Everybody is using cloud nowadays, right? So whether we know or not, we are using cloud, right? So even like many of these Gmail many of these Google services that we use, right? So these are actually cloud-based services. So like this, there are so many different types of services that we are all using, and we do not know that these are actually cloud-based. But behind the scene, if you dig further into, you will be able to know that actually these are cloud-based services, right? And that is the beauty, right? So seamlessly many things are happening. We do not know what kind of technology, where my program is getting executed, but it is getting executed and giving me the results. And when my program is getting executed, maybe there are thousands of other um, people who are also executing their programs on the same computer resource, which may be located in somewhere in, let us say, South Africa or in South America or somewhere. And we do not know. We simply know that we are executing our program, and behind the scene, many things are happening which we do not know, we do not care about, and all we need is the service that I want to execute my program and I want to get the results, right? So that is what is very beautiful and attractive about cloud computing. So let us try to understand this evolution of cloud computing in a little bit further detail. So there has been a concept of cluster computing, and cluster computing, I think many of you have heard about this term. So cluster computing basically is all about forming clusters of computers, and these clusters of computers, these computers can be, in a cluster connected in certain way, which may be tightly or loosely connected, right? And together, those computers, they perform certain tasks, right? So it's not one computer performing a task, but a network of a connected set of computers which are going to perform a particular task, and that is what the cluster is all about. And cluster computing is all about computing in in that kind of cluster. Okay, so then comes grid computing. And so grid computing is about, so the whole idea is very similar to what I just said about cluster computing, but in grid computing, things are not localized, right? So you have a lot of different computers, computing resources, which are distributed across, right? Geographically distributed, right? So these distributed computers and computing resources, they work together, and then they work on different non-interactive workloads, right? And these non-interactive workload means what? Non-interactive workload means, like, you let us say that you pump in some kind of a job to be executed, and you do not wait for the response to come back, right? And you start another kind of, in a very asynchronous kind of manner, these workloads are executed, right? So you do not, I mean, once you send a query or some kind of a job for execution, you do not really have, you are not held back for executing the other jobs, right? So that's the non-interactivity in workload execution. So in grid computing, in a distributed manner, you have resources which are geographically distributed, and this kind of execution happens of different workloads in that kind of environment. So grid computing is, it gives you the facility of having multiple computing resources being utilized, but these resources do not have to be all co-located. They can be distributed in different locations. Okay, so that's about grid computing. Then comes utility computing. Utility computing, basically, this is something that I was highlighting yesterday when I was talking about utility computing. Utility computing basically talks about using computers as utility, using computing facilities as utility. Okay, so what is that? What is that all about? So basically, utility computing, it talks about using computer just like an utility, like electricity or water. And this is the example that I also told you. Let me just do it once more. Let me just tell you once more. So in the same way as we have utility like electricity, in the same way as we have utility like water, so computing is also like a utility which can be offered to you uh, on kind of on-demand basis. So whatever you need, you use, and it will be chargeable. So it is a metered service. So so the amounts of the units of usage of computing resources that you have, you will be billed according to the number of units you have subscribed to or the number of units you have utilized, right? So that is the beauty of utility computing. So so the whole idea is to provision different resources, packaged resources for computing and storage as utility, right? So cloud computing, basically what it did, what it does is that it utilizes the concepts of all these three, particularly grid computing and utility computing. It packaged the concepts of grid computing, utility computing together and provisions different resources to users, okay, through certain mechanisms of resource pooling, for example, and many others, to offer these resources ubiquitously, dynamically, on demand, right? So essentially, cloud computing is not something brand new, right? So cloud computing, before it came into being, it was existing in different forms. So server farms were all existing. There is a concept of something called virtualization, which we will learn later on down the semester. So virtualization, offering these different resources on demand, getting billed for those resources, billing the resources to the end users. So these are all packaged together and offering these resources without the end users having to buy these resources by the infrastructure, to use them, right? So if I have to use certain computers, etc., or some servers, etc., I really do not need to buy the computers, install them, deploy them, maintain them, and so on. All I need to do is to go to some cloud service provider portal, register for those resources, and we can start using them, right? So somebody was, for example, yesterday, somebody was mentioning the name AWS, right? So there are so many, nowadays, there are so many cloud services offered by different cloud service providers. For example, there are products like AWS, EC2, then you have even Google cloud services. So like that, actually, there are earlier, actually, when I started, working on cloud computing, those days when cloud computing was very new, there was another one which was called eucalyptus, right? So eucalyptus is no longer that popular, but so eucalyptus was something that was popular those days, but gradually there are other popular cloud platforms that have come into being, and so cloud is being used using these different technologies, is provisioned using these different technologies through the help of some kind of a service provider. So let us very briefly, this is not a course on cluster computing or grid computing, but very briefly, let us try to understand the differences between these different technological paradigms. This is all about cluster computing. So we have different nodes which are centrally managed, right? And the end users basically can get access to these different nodes, these different computers, to get their jobs done. And this job, the task, is executed by this cluster and not necessarily by a single computer in the cluster. Okay, so this is the core idea of how cluster computing works. Going beyond, grid computing took it little forward. These computers are the nodes that you saw in cluster computing. These are no longer uh, these are no longer these are no longer co-located, but these are distributed, right? So these are geographically distributed. So one of these computers could be located in Kharagpur, another in Kolkata, another in Delhi, another one maybe in somewhere completely distant. But together you can form a grid, and this grid can help you to offer these different services. So what is the beauty? The beauty is that this geographical distribution gives you a lot of advantages. This geographical distribution gives you a lot of advantages. So one of these computers could be belonging to IIT Kharagpur. Another computer could be belonging to BARC. Another computer could be belonging to IIT Mumbai. Another computer could be belonging to another organization. But these could be all these different computers could be part of the same grid. So you form that grid. For example, I will just give you an example. I am the principal investigator of a project which is in France. It's a India-France project on cloud computing, and so what we are using is something called the Grid 5000, which is basically a huge network, geographically distributed network of computers that exist in different educational institutions in France, different research labs in France, research labs and educational institutions in France. It is called the Grid 5000. So that Grid 5000, we use to get some of the jobs done based on the project objectives that we have, right? So it's a very prominent platform that is based out of France, and we are all utilizing it for our project on cloud computing. So interestingly, probably somewhere down the semester, I will talk about more about it. So what we do is not simple cloud computing, but it is called fog computing. So the name of our project is Fog City, right? So what we are doing is not merely cloud computing, but something called fog computing, which I will also cover as I promised you. So this fog computing being utilized in a smart city environment, right? In that project, and it is called the Fog City. The name of the project is Fog City. So this is just to give you an idea that fog computing is something which tries to take advantage of some of the limitations that exists with cloud computing, right? And what are those limitations that we will learn later on, not today, right? So so we will look into more of fog computing and cloud computing later. So this is grid computing. So here also you have a grid coordinator, and this grid coordinator basically is the one which helps you to coordinate between the different nodes that are subscribed to in that grid. Cloud computing, it is a service offering. It is more of a service offering. Obviously, there is a lot of technological aspect of it, but those technological aspects, according to me, are certain things that have been existing since long before cloud computing came into being. So whatever you learned about grid computing, think of infrastructurally having a similar kind of thing, but on top you wrap it up with certain software and service platforms which can deliver these services to the end users. You can visualize cloud computing to be wrapped up wrapped up across beyond grid computing with certain types of attractive services. Okay, so something like grid plus services is equal to cloud. Not exactly, let me tell you, but just so that you can visualize a bit, what it is all about, right? But there is much more to it. I probably oversimplified whatever I told you, but so there are so many different aspects which we will cover during the entire semester. So yeah, so I'm just trying to take a tab on the time, right? So we have a little bit more time. So yeah, so you see that cloud computing is a kind of stack that is implemented, where you have storage, you have services, you have applications which are running. There are different other verticals such as management, security. Even nowadays there are different other aspects of trust, privacy, etc. So these are certain things which basically cut across these horizontals like storage, services, and applications, right? So this service centricity is very important and unique of cloud computing. And this service centricity is the one which makes cloud computing so attractive. Okay. So you have so many different applications which are running, and at the bottom you have a huge giant storage, giant processors which are there and are giving the end users, which are sitting right on top of this stack, as you can see from this particular figure. The end users, they get access to these different services via some network, and typically that network is the internet that we all use. Okay. Lot of management aspect is involved, lot of security is involved. Management, why? The reason being that all of these bits and pieces, these different components that we talk about, you have to tie them up appropriately, quote unquote tie them up, right? You have to tie them up appropriately, and for that, as you can probably visualize, that you need a lot of management involved, right? So a lot of management of these tying up is involved, right? And parallelly, you see that when you have all your storages, servers, etc., all these computational resources which are going to serve the end users, if they are located in different locations, different places, and these are part of that common pool, you have to ensure that there is adequate amount of security in place. Otherwise, my software that is running on the cloud, and in turn, which is running on some some device which does not belong to my organization, right? So how do I ensure that my data, my my program is secured? How do I ensure that? So you need to have appropriate levels of security to be in place. Now, security is very broad. Security encompasses issues of encryption, decryption, which you all know, but there is also something called access control. So access control is very important to security, something part of information security. So this access control, appropriate levels of access control will have to be built in order to offer these services appropriately to the end users, and so that the end users can also have faith on the platform that is being provided. So that is why one needs to be very much careful about the kind of cloud platform that one is using. One means the end users. So if I am subscribing to XYZ cloud service, I have to be careful about what sort of cloud service what sort of cloud service I am using, right? So I have to be careful about that. Okay. So the final thing is the participants. These participants in the cloud computing, so broadly you can classify them into three groups. The first is the end users, who are basically the ones who are going to enjoy the different computational services, right? So these computing services which is offered as utility, the end users are the ones who are consuming these services. So these end users are called as consumers, right? And these end users, they are using these cloud services for fulfilling different personal activities as well as different commercial or business activities. So the second group is basically the cloud service providers, right? So in the same way as you have your internet service provider, ISP, in the same way as you have different other service providers, for example, you have electricity service provider, telephone service provider. You have so many different service providers nowadays. So here also you need some kind of a service provider very similar to that, which is called the cloud service provider. The cloud service provider basically offers a variety of functions such as infrastructure, applications, tools, and others for use by these end users, the consumers, which I talked about a little while back, right? So service providers. And then you have the designers, who are basically the ones which are building these applications and with the help of different types of tools. So they are using these applications and tools for building these cloud platforms, right? So typically when we talk about cloud platforms, typically we'll be talking about these three participants, three different actors. In system development you call them as actors. So which actors? Consumers, service providers, and the designers who are actually going to build these services for for the end users to enjoy. With this, I'm going to stop here today. I'm going to continue next week with the rest of the concepts. So I will let me just ask you if you have any question so far. Just feel free to ask. So if you have any question, just feel free to ask. Okay, so let me just regarding the regarding the project. So some of you probably had a lot of concerns. So we'll try to have something which will be doable by all of you. So I will probably give you more options, right? So through these options you will be able to have different ways in which you can fulfill the project requirement. But the project is going to be there. I cannot eliminate the project. So project is going to be there, but we'll have different options which will ensure that all of you can do your projects, right? Okay, any question before we end here? Okay.
Hello, sir.
Yes.
Sir, we are not able to access the Moodle right now. There, we need to network key probably.
Okay, we will share with you. Okay. So I do not know actually. I thought that the TAs have done it, right? So if not, I request the TAs to send the key for the Moodle. Okay. And everything will be put on Moodle. All these resources are going to be put on Moodle, right? Okay. Okay. Thank you. All the best. And enjoy your weekend.